All right, class, let's begin. In nomine Patris et Filii et Spiritus Sancti. Amen. Pater noster, qui es in celi, sanctificetur nomen tuum, adveniat regnum tuum, fiat voluntas tua, sicut in cielo et in terra. Panem nostrum quotidianum da nobis hodie, et dimitte nobis debita nostra, sicut in nos dimittimus debitoribus nostris. Et ne nos inducas in tentationem, sed libera nos a malo. Amen. Sancte Iosef, ora pro nobis. In nomine Patris et Filii et Spiritus Sancti. Amen. All right, so Latin Our Father for you, and let's get into the math. So we're still in the derivatives chapter, okay? And this section is called product rule, okay? So when you hear the word product, you should be thinking about multiplying, and that's exactly what will happen. So our objective today is to use the product rule to find the derivative of a product of two functions, okay? So what have we already seen? Well, we've already seen the power rule is used to find the derivatives of powers, okay? A power is an expression of x to the n power, right? So x to some power of a number, okay? So x to the sixth, for example. All right, we've also seen we can find derivatives of all the six main trig functions, okay? And we just did that on Monday. And you got to memorize those, okay? And now we'll find the derivatives when functions are multiplied together, okay? So our example one is to find y prime if y equals x squared times the sine of x, okay? So we cannot use the power rule, okay, since x squared and sine of x are not both powers and cannot be combined into one power. So what do I mean by that? Well, remember when we had functions like this, now I want to be clear, the rule that we're using, you can use the power rule here, which you don't know yet. But I would say that it's not necessary because I can distribute this x squared to each of the term inside the parentheses, right? So why use a rule when I can just distribute and then use the easier rule, okay? So when you're multiplying x squared and sine x, right, you can't make it sine of x cubed, right? You can't, you can't do anything. It's just... and we definitely can't use power rule because the sine of x is not a power, right? It's a different function, okay? So for this reason, we go to the product rule. So the product rule is a rule we use to find the derivative when we're multiplying two functions that we just can't simplify anymore, okay? So what's our goal? So number one, we're gonna call the first function that we're multiplying f of x, or and I should say f, not f prime. So we're calling the first function f and the second function g. So I got a little ahead of myself when I was doing this, okay? So the first function is f of x, well, we're going to call it f. The second function is g of x, we're going to call it g, okay? And again, I got ahead of myself here. So in our example one, let's call x squared f, right, or f of x, and sine of x we're going to call g, okay? And here's the rule. The derivative of the two functions multiplied is the derivative of the first times the second plus the first function times the derivative of the second, okay? Or you can write it this way. I like this way better. It's easier for me to remember. Okay? So f prime g plus g, actually, I will say this. I don't even know what just happened. Okay. So f prime g plus f g prime. F prime g plus f g prime. I don't know. That's how I remember it. Now, I don't say it the same way, right? The derivative of the first times the second plus the derivative of the second times the first, okay, is how you would say it, not in that specific order. But I would just remember this, f prime g plus f g prime. F prime g plus f g prime. So you've just got to remember the rule here. So it's f's derivative times g plus f times g's derivative, okay? Whatever way you remember it, I remember it as f prime g plus fg prime. In the product rule here, right, the different way to write it, you know, it's not written the same, right? So in this example, they have the f prime of x times g of x right here, and then they have the f of x times g prime of x right here. Don't worry about it. F prime g plus fg prime. F prime g, right, and you know those are multiplied, plus fg prime, okay? I don't know. That's my favorite way to remember it, okay? So that's what I'm going to tell you to remember. So if you can find a better way, but in any case, so how does this work out? So f prime g plus fg prime. So we're going to call this one f, and we're going to call this one g, okay? So we're going to find the derivative. So we're going to say y prime equals f prime g plus fg prime. So that gives me the derivative of the first one, which is 2x, okay, times g sine of x, plus f, which is x squared, times g prime, which would be the cosine of x. Okay? All right, that's it. F prime g plus fg prime. F prime g plus fg prime. There you go. Okay, let's try another one. Find y prime if y equals those functions. So again, this is f, and this is g. So y prime is f prime g plus fg prime. Remember, prime means derivative, okay? Just in case. So y prime equals f prime, negative sine of x, times g, which is the sine of x. Okay, plus f, which is the cosine of x, times g prime, which is the cosine of x. And we can actually simplify this one. Negative sine squared of x plus the cosine squared of x. Okay? That's it. Okay? So, you know, in this problem, we could have factored out an x. You just want to keep your eyes open for that, but not required. Now, here's an example 3, where if you notice, right, you can do this a couple ways, okay? Number one, let's do it the product rule way, okay? So again, let's call this function f and this function g, okay? So y prime equals f prime g plus fg prime. Okay? And so we get f prime, 3 times g, 2x minus 5, plus f, 3x plus 1, g prime, which is 2. Okay? Notice I'm writing this rule out every single time so that I can remember it, right? It'll help me remember it. So I get 6x minus 15 plus 6x plus 2. And that gives me 12x minus 13. And that's my derivative. Now, if you remember from Friday's Edpuzzle, this is actually an example of a problem you could FOIL, right? So this one has 2 ways to do it. They don't all, right? The last one didn't, and the one before that didn't because we cannot simplify them at the start, okay? So, if we were to FOIL, we'd get y equals 6x squared minus 13x plus 5. And when we take the derivative, we get 12x minus 13. So in this case, it's a lot easier than using the product rule, okay? So just be on the lookout though, right? You don't always need to use the product rule. Sometimes you can simplify, and that's why we went through simplifying, because you always want to simplify your expressions if you can at first, okay? All right, 2 more to go. So find y prime if y equals 5 times the secant of x times 9x squared, 9x to the 4th minus 7x squared plus 2. So a few tricks, right? Number 1, this 5, remember, it doesn't matter what order you multiply in. So I can multiply this 5, right, by this, and by this, okay? I'm not going to distribute the secant of x because you have to do the product rule a couple times in that case, which we're not going to do. So y equals the secant of x times 45x to the 4th minus 35x squared plus 10. Okay? And now again, I cannot combine the secant of x and what's in the parentheses on the right, so I have to use the product rule, okay? Because I'm multiplying two functions. So I'm going to call this f, call this g. So y prime equals f prime g plus f g prime. Okay? So that means secant of x, tangent of x, times the function g, okay, plus f g prime. So now the derivative of 45x to the 4th, okay, that's going to be 180x to the 3rd minus 70x. Whew. Now again, that's ugly, right? We'll stop there, okay? But you could factor out a secant of x from both terms, right? So just a heads up there. Oh, actually, there's more. I didn't know that. Okay. Now, again, what happens if they don't tell us what the function is? It's okay. We use the same concept. So in this problem, I'm going to call h of x f, and I'm going to call cotangent of x g. Obviously, h of x already has a name. It's h, but... So we're going to say f prime g plus f g prime, right? That's the same thing we've been doing for the last 5 examples, or 4 examples. So now y prime is f prime g, so that's h prime of x, times the cotangent of x, right? Because we don't know what h of x is. Okay, so we take the derivative of it. Plus f, which is h of x, times g prime, okay? The derivative of the cotangent of x is negative cosecant squared x. Okay? And then we're done. Okay? So, again, just for a general function, right, you would do the same thing. H of x can be any function you want it to be, all right? So, last one. Find y prime if y equals 4 over x to the 5th times the cosecant of x. So again, y prime is f prime g plus f g prime. Y prime equals, so again, let's identify our functions first. This is f, this is g. So f prime g, so again, I'm actually going to rewrite this now because I see You know, so don't feel free to take another step, okay? Like I said in class, this is not a rush to get done, right? Just like, you know, when you're praying, you wouldn't just rush to get it over with, right? You want to do it well, okay? Same thing applies. So now f is the first function again, right? So f prime g would be negative 20 x to the negative 6 times g cosecant of x plus f, which is 4 over x to the 5th, times g prime, okay, which is negative cosecant of x times cotangent of x, okay? And then to clean this up, no negative exponents, we get negative 20 cosecant of x over x to the 6th minus 4 cosecant of x cotangent of x all over x to the 5th. Now, if you really wanted to be cute, you'd multiply this guy by x over x so that these two could have the same denominator. I don't have to go through all that, okay? But I'm just telling you what you could do, right? So, you know, let's play it out, actually. If you multiply this by x over x, you'd get negative 20 cosecant of x minus 4 cosecant of x cotangent of x, for x, I should say, all over x to the 6th. Okay? So, and then you could even go farther, right? You could take out negative 4 cosecant of x, and then you're left with 5 minus x cotangent of x all over x to the 6th. So I'm not saying you have to go there, right? You could stop here. Okay? But just saying that, you know, there's always more you could do, generally speaking, right? You could make the fractions have the same denominator, right? You could factor out, as in this problem, you could factor out a secant of x, right? If we go back to this problem, you could factor out x, right? I'm not saying it's required, but I would always just keep a lookout, right? You always want to have factoring on your mind, okay? Okay? Because you never know when you're going to need to use it, okay? It's one of those arrows in your quiver, let's say, okay? All right, but that's it, right? So again, the summary of today's lesson, f prime g plus f g prime, okay? That's the product rule, okay? Okay, so this is the derivative of f, this is g, this is f, and that's the derivative of g, okay? Just as a recap. Okay, guys, so your homework will be on Classroom, and I hope you have a wonderful day, wonderful weekend, and I'll see you all on whenever I see you next.